tripping mechanism in miniature circuit breaker. The mechanism comprises of two units as thermal tripping and magnetic tripping. Thermal trip unit. The thermal trip unit protects against overload currents. The thermal unit is based on a bimetal element located behind the circuit breaker trip bar and is part of the breaker's current carrying path. When there is an overload, the increased current flow heats the bimetal, causing it to bend. As the bimetal bends, it pulls the trip bar, which opens the breaker's contacts. The time required for the bimetal to bend and trip the breaker varies inversely with the current. Magnetic trip unit. The magnetic trip unit protects against a short circuit. The magnetic trip unit consists of an electromagnet and an armature. When there is a short circuit, a high magnitude of current passes through the coils, creating a magnetic field that attracts the movable armature towards the fixed armature. The hammer trip is pushed against the movable contact and the contacts are opened. Types of MCB based on tripping characteristics. MCBs are classified into different types according to tripping over the range of fault current. The important MCB types are Type B MCB, Type C MCB, Type D MCB, Type K MCB, Type Z MCB. Type B MCB. This type of MCB trips between 3 and 5 times the full load current. Type B devices are mainly used in residential applications or light commercial applications where connected loads are primarily lighting fixtures, domestic appliances with mainly resistive elements. Type C MCB. This type of MCB trips between 5 and 10 times the full load current. This is used in a commercial or industrial type of application where there could be chances of higher values of short circuit currents in the circuit. Type D MCB. This type of MCB trips between 10 and 20 times full load current. These MCBs are used in specialty, industrial or commercial uses where current in rush can be very high. Examples include transformers or X-ray machines, large winding motors, etc. Type K MCB. This type of MCB trips between 8 and 12 times the full load current. These are suitable for inductive and motor loads with high inrush currents. The K and D curve breakers are both designed for motor applications where ampacity rises quickly and momentarily during startup. Type Z MCB. This type of MCB trips between 2 to 3 times the full load current. These types of MCBs are highly sensitive to short circuits and are used for the protection of highly sensitive devices such as semiconductor devices. Types of MCB based on number of poles. Another practical way of distinguishing MCBs is based on the number of poles supported by the circuit breaker. Single pole MCB. A single pole MCB provides a switching and protection only for one single phase of a circuit. Double pole MCB. A two-pole MCB provides a switching and protection both for a phase and the neutral. Three-pole MCB. A triple or three-phase miniature circuit breaker provides switching and protection only to 3 phases of the circuit and not to the neutral. Four-pole MCB. A four-pole MCB is similar to TPN, but additionally, it also has a protective release for the neutral pole. This MCB should be used in cases where there is a possibility of high neutral current flow through the circuit, as in cases of an unbalanced circuit. Selection of right MCB. It is very important to select a right MCB. The decision to use Type B, C or D miniature circuit breakers for final circuit protection in residential, commercial, industrial or public buildings can be based on a few simple rules. However, an understanding of the differences between these types of devices can help the installer overcome problems of unwanted tripping or make a suitable selection where lines of demarcation are less clearly defined. Type B, C and D are used for overcurrent protection of cables in accordance with IEC or EN 60898-1. Type K for the protecting motors and transformers and simultaneous overcurrent protection of cables with overload tripping based on IEC or EN 609472. Type Z for control circuits with high impedances, voltage converter circuits and semi-cable protection and simultaneous overcurrent protection of cables with overload tripping based on IEC or EN 609472. Safety precaution. As an important note, I would like to add here is children do not know how to handle electrical devices. So please do care to place them in the right place where their contact is prevented from the device. Post your queries in the comment box.